Good morning, scholars, and welcome back. Today I'm going to be doing a quick review of all the trig stuff that we've done so far with a handful of problems in preparation for the test or quiz coming up. So we'll call this trig review. And this might just be part one, depends how quickly I go through these problems. So these are problems that should look familiar. There's going to be a lot of overlapping information. Let's go ahead and jump right into it. So say I've got a point, let's call this one problem one. Say I've got a point P, and its coordinates, it's on the unit circle, it's negative square root of 2 over 2, comma, square root of 2 over 2. Now, you are asked to find what all of the values of the angle are. So if I draw out my unit circle, looks kind of like this. This point's going to be over here. I'm going to have some angle theta. And so I'm trying to figure out what all of the values of the trigonometric functions are at this particular point. Well, all I need to remember here to get started off is that the x value is going to be the cosine. So the cosine of the cosine of theta is going to be equal to the negative root 2 over 2. That's my first one. Now, if you remember, I need to find 6 of them. So the next one is going to be my sine value. That's the next easiest to figure out. And that's always going to be my y value. So cosine is associated with the x, sine is associated with the y. So the sine value is going to be, square root of 2 over 2. Now the tangent value, this is not too much harder. I just need to remember that this is going to be either sine over cosine or y over x. So if I take my y value, my x value, or my sine value, my cosine, it's going to be the same thing. I'll end up with square root of 2 over 2 divided by negative square root of 2 over 2. Now, of course, when I've got a fraction on the bottom and I'm dividing by it, I can flip it and bring it to the top. So this is going to be equal to square root of 2 over 2. That's this guy right there, multiplied by, and then I flip this guy when I bring it up. So instead of square root of 2 over 2, it's 2 over square root of 2, and there's a negative sign there. So getting rid of these cancel more or less, and I'm just end up with negative 1. So the tangent of theta, just rewriting it, is going to be equal to negative 1. Cosine, sine, tangent. Now I still need to find 3 more. I still need to find my cosecant, my secant, and my cotangent. These aren't too bad, just remembering that the cosecant is the reciprocal of not the cosine, but the sine. And so the sine is root 2 over 2, so the cosecant is going to be 2 over root 2. Now this root 2 I have on the bottom, that's troublesome. In order to get rid of that, I just multiply by square root of 2 over square root of 2. And I just end up with 2 square root of 2, and then I get square root of 2 over square root of 2 multiplied by each other, which is just going to end up being 2. The 2's cancel, it simplifies, and I'm just left with square root of 2. So the cosecant of theta is square root of 2. Now the secant of theta, I can do a similar sort of thing and just say this is going to be equal to the reciprocal of this one, of the cosine, which is going to be 2 over negative square root of 2. And I can do the same thing, multiply it by square root of 2 over square root of 2 to get rid of this rational denominator, which is what that's called when it's got a square root on the bottom of the fraction. So to get rid of that, I'd follow the same sort of idea. I end up with negative square root of 2, or negative 2 square root of 2, and then root 2 times root 2 is just going to be 2. The 2's cancel, and I just end up with negative root 2. Now to finish it out, the cotangent of theta is just going to be 1 over the tangent. In this case, the tangent is negative 1, so I just end up with 1 over negative 1, which is going to be equal to negative 1. So writing out all my answers so that I've got them all nice and neat, and it's easy to grade, I can see cosine of theta is equal to negative root 2 over 2. The sine of theta is equal to root 2 over 2. Tangent of theta is equal to negative 1. Cosecant, root 2, secant, negative root 2, and the cotangent. got all my answers written out there. They're boxed in, they're nice, they're neat, they're ready to go. Fantastic. Okay, next thing I want us to try to figure out is remembering our unit circle, or constructing a unit circle on the quiz, which is something that I'm going to have you guys do. I want you guys to, I'm going to give you some values. For example, the sine of pi over 3, let's say 2a here, sine of pi over 3, and I want you to tell me what that value is. Well, if we look at our unit circle, and we go to pi over 3, and I'm not going to draw out the full unit circle here. I trust you guys know how to do that. You did really well on that quiz. But I find that the coordinate point at pi over 3 is going to be 1/2 root 3 over 2. Now the sine of pi over 3, of course, that's just associated with the y value, so that I know that the sine of pi over 3 is just going to be equal to root 3 over 2. And that's the answer. Now b, let's check out the cosine. Here I want to do the cosine of not pi over 3, but let's do 2 pi over 3. Let's make it a little bit trickier. Now if I go to 2 pi over 3, I find that that coordinate point is associated with negative 1/2 comma root 3 over 2. So this one was positive 1/2, this one's a negative 1/2, and then root 3 over 2. And so the answer, of course, the cosine is associated with the x value, so then I know that the cosine of 2 pi over 3 is equal to just this negative 1/2. Just like that. And the last one, of course, is I need to figure out what the tangent is. Okay, and so C. In this case, I want to figure out what the tangent of, oops, not theta. I want to know what the tangent of 0 is. Tangent of 0. So if I look at my unit circle, I find that my coordinate point associated with 0 angle, is 1, 0. It's right on the x-axis. So 1, 0, I remember that the tangent is y divided by x, or sine over cosine. And so I know that the tangent of 0 is going to be equal to 0 divided by 1, which is going to be equal to 0. And that's my answer. Just like that. Okay, moving on. Review problem number 3. So this one is really, really similar. Not only do I want to know what the value is at the particular point, so I'll say 3a. So here I'm going to give you cosine of pi over 3, really similar. I want to know what that point is, or what the value here is. Of course, on our unit circle, we can look up pi over 3. This was also just on our previous example. I know that at pi over 3, the coordinate point is 1/2 root 3 over 2. So I know that the cosine of pi over 3 is going to be the x value, which is going to be 1/2. Now, in this particular problem, I'm not quite done yet. I also want to know what the cosine of negative pi over 3 is. This is going back to even and odd functions. Now, just because I know that the cosine is an even function, I can automatically solve this and say, well, it doesn't matter if this is a negative or a positive. If this is whatever this is, the negative value of that is going to be exactly the same. So I know that negative pi over 3 is just going to also be equal to 1/2. And you can look this up on your unit circle and see it as well. Let's do one with the sine. So let's do the sine of 2 pi over 3. Once again, from our previous example, or on your unit circle, you know that this is associated with negative 1/2 root 3 over 2, the point on the unit circle. And so once again, we're going to look at the y value for the sine. So here we've got the sine of 2 pi over 3 is going to be equal to this y value right here, which is root 3 over 2. That's that answer. But also, once in this one, similarly to this one, I also want to know what the sine of negative 2 pi over 3 is. Well, because the sine is an odd function, when this becomes a negative, then you know your answer is also going to become a negative. So this is going to be negative 3 root 3 over 2. Okay, so even functions, it doesn't matter if this is negative or positive. These are going to match. This one, it does matter if these are negative or positive because they're going to match across this way, or in this case, a positive 2 pi over 3 is going to be a positive root 3 over 2. Negative 2 pi over 3 is going to be a negative root 3 over 2. Okay, so if these signs flip, then these signs flip. Okay, I've got 2 more for this review. Let's see, problem number 4. I'm going to start you guys off. This is very, very similar to the first problem you guys did. I'm going to start you guys off with some information. I'm going to say the sine of theta is 3 over 5, and the cosine of theta is going to be equal to 4 over 5. And with this information, I want you guys to be able to calculate all the other trigonometric identities, which basically just means I want you to find tangent, cosecant, secant, and cotangent. So I'm just going to write them over here as sort of my answers. I'm just going to start. So this is going to be my answer column over here. Now, using the trig identities, starting off with the tangent, I know that tangent is sine over cosine. So putting my work over here, I can say the tangent of theta is going to be 3 over 5 divided by 4 over 5. Once again, when I'm dividing fractions, I can take the bottom one, flip it, and then multiply them. So I can say 3 over 5 times, that one stays normal. Then this bottom one, I flip it when I bring it up, and I say 5 over 4. So the 5's cancel, and I'm just left with 3 over 4. So the tangent of theta is going to be 3 over 4. Now the cosecant, that's associated with the reciprocal of the sine. So my sine is 3 over 5. My cosecant is going to be 5 over 3. It's going to be the opposite. Now my secant, that's associated with the cosine. Same thing. It's just a reciprocal. So cosine is 4 divided by 5. My secant is 5 divided by 4. Now my cotangent, I'm looking at my tangent value here, right? So once I look at my tangent value, I'm finding the reciprocal of that. And whereas my tangent is 3 divided by 4, my cotangent is going to be 4 divided by 3. Just like that. Nothing to it. Now the last one I've got involves a Pythagorean identity. So the Pythagorean identity states that the sine squared of theta, or anything, plus the cosine squared of theta, and by anything I mean it could be any variable, it could be t, it could be x, it doesn't matter, is going to be equal to 1. So sine squared plus cosine squared is equal to 1. So here I'm going to give you a sine of theta is equal to 7/8. And I want you to find the cosine of theta using this. Well, that's not too terribly difficult. I know this. I can sort of plug and chug and do a little bit of algebra and figure it out. Nothing too complicated. So sine squared of theta, that's equal to 7/8. Just doing some substitution. I know sine of theta is 7/8. So sine squared is going to be 7/8 squared plus the cosine squared of theta is equal to 1. So 7/8 squared, that's going to be equal to 49 over 64 plus the cosine squared of theta is equal to 1. So now I can just subtract this fraction from both sides. Now 1, I need to rewrite 1 as a fraction over 64, trying to find that common denominator. And so my next line I'm going to say is going to be the cosine squared of theta is going to be equal to, and 1 is just going to be 64 over 64. Just rewriting 1 as a fraction. Minus 49 over 64. Now 64 minus 49 is just going to be equal to 15. So here I get 15 over 64. Now, because I've got this cosine squared, so I've got the cosine of theta squared, just rewriting this as this, they mean exactly the same thing, is going to be equal to 15 over 64. Now, because I'm trying to solve for cosine of theta, I need to just take the square root of both sides, and I end up with the cosine of theta is going to be equal to, now the top I'm going to write as root 15. The bottom, because it's the square root of 64, I can just write as 8. So the cosine of theta is going to be equal to 15, square root of 15 divided by 8. That's all the review for now. I'll do a review part 2, and we'll go on from there. See you guys tomorrow.